A humanoid robot just ran a half marathon. Yeah, that's right, an actual 21-kilometer race on the streets of Beijing. It wasn't a simulation, it wasn't a gimmick, and it wasn't remote-controlled. It was Tiangong Ultra, a fully autonomous robot built to run like a human, and it crossed the finish line after nearly 3 hours of continuous motion. This event wasn't just about endurance, it marked a breakthrough in robotic mobility, balance, and energy control. In this video, we'll explore how this robot pulled it off, and why it may have just redefined what humanoid robots are truly capable of. Running is something we take for granted, until a robot does it. Unlike robots that roll or glide, Tiangong Ultra ran step-by-step through the streets of Beijing in the world's first humanoid half-marathon, completing the 21.0975-kilometer race in 2 hours, 40 minutes, and 42 seconds. That's not Olympic speed, but for a bipedal machine powered by algorithms, sensors, and batteries, it's honestly groundbreaking. To achieve this, Tiangong Ultra was equipped with long, biologically inspired legs, designed to replicate human running mechanics. But hardware alone isn't enough. What made this possible was a series of critical engineering upgrades. The development team at the Beijing Humanoid Robot Innovation Center enhanced the robot's joint system, making it more stable, shock-resistant, and heat-resistant. Factors that are essential when a machine is expected to maintain balance over such a long distance. More impressively, the robot's motion control algorithm was revamped to adapt to various road textures, inclines, and curves in real time. These weren't flat indoor surfaces. This was an open-air event with unpredictable terrain, subtle elevation shifts, and environmental variables. The new algorithm allowed the robot to increase its top speed from 6 kilometers per hour to 12 kilometers per hour. A major leap in performance that bridged the gap between robotic precision and real-world adaptability. Battery management was another win. While human runners hydrate and fuel up, Tiangong Ultra had to switch out batteries. But it only needed 3 battery swaps for the entire race. That level of energy efficiency, under continuous physical strain, is a feat of system optimization. This wasn't a short demo or a choreographed lab sequence. It was a sustained, high-pressure marathon of autonomy, requiring physical capability and algorithmic foresight. Tiangong didn't just walk or jog, it demonstrated a new era of robotic movement, proving that long-distance, terrain-aware mobility is no longer exclusive to biological beings. On the surface, it may seem like just a cool tech stunt, let a robot run and grab some headlines, but in reality, this was a high-stakes engineering challenge disguised as a sporting event. And the stakes were far higher than who crossed the finish line first. The race functioned as a real-world stress test, forcing the robot to operate without lab conditions, safety nets, or external assistance. It had to deal with complex variables like shifting weather, uneven road textures, crowd interference, and spontaneous adjustments. Every step was data. Every slip, adjustment, or battery change gave engineers insights that would be impossible to gather in controlled environments. This is where Tiangong Ultra becomes more than just a flashy machine. It becomes a platform for innovation. Its performance helps developers refine critical systems like dynamic balance, low-latency decision-making, sensor fusion, and environmental awareness. These are the building blocks for robots that won't just run, but eventually walk among us in hospitals, homes, and hazardous zones. The race also served a broader purpose. It captured public imagination. According to Hugo Award-winning author Liu Cixin, this event helps society reframe how we see humanoid robots, not as sci-fi threats or gimmicks, but as real tools for solving real problems. Robots that can move like humans could one day assist the elderly, support patient care, or perform physically demanding tasks in places where humans can't or shouldn't go. There's also the symbolic angle. This wasn't a Boston Dynamics showcase or a Tesla prototype reveal. It was a public event held in China, in broad daylight, with media coverage and national pride attached. And it worked. The Tiangong Ultra Half Marathon wasn't just a test, it was a declaration of technological readiness. Not perfect, but promising enough to change how we define the limits of humanoid robotics. Now let's talk about what makes Tiangong Ultra not just impressive, but strategically important. This robot wasn't created by a lone genius in a garage. It's the product of a sophisticated collaboration involving state-owned enterprises, private tech giants, and cutting-edge research labs. That's no accident, it's a glimpse into China's broader strategy to become a global leader in humanoid robotics. The Beijing Humanoid Robot Innovation Center, which developed Tiangong, is 43% owned by two Chinese state-owned enterprises. The rest of the ownership is split equally between Xiaomi Robotics and UBTech, two major players in China's AI and robotics ecosystem. This unique structure allows for deep funding, advanced research and development, and strategic alignment with national tech goals. It also reflects how China fuses state ambition with private sector innovation, a sharp contrast to the mostly private-led robotics efforts in the West. When Tiangong ran, it wasn't just a technical feat, it was soft power in motion. It told the world, we can build robots that perform in real-world conditions. And we can do it better, faster, and at scale. What's more, the name Tiangong isn't random. Though spelled the same in English, the characters used for the robot translate to celestial craft, while the space station's module of the same name means heavenly palace. Still, the association is intentional. It subtly ties the robot to China's ambitions in space, tech, and national identity. From a geopolitical lens, this kind of public demonstration serves a dual purpose. Domestically, it galvanizes support and excitement for the country's innovation agenda. Internationally, it challenges dominant narratives that the future of robotics belongs only to the United States, Japan, or South Korea. China is clearly stating it has the talent, infrastructure, and ambition to compete and perhaps even lead. And economically, the timing couldn't be better. As labor shortages rise and global populations age, the demand for humanoid assistance is exploding. Events like this position Tiangong and its makers to capitalize on emerging markets in elder care, healthcare, smart logistics, and home automation. Tiangong Ultra isn't just a robot, it's the frontrunner in a race to define the next generation of intelligent mobile machines. And from what we've seen, it's off to a running start. Tiangong Ultra didn't just run a half marathon, it ran straight into the future. This wasn't about speed, it was about proving that humanoid robots can handle real-world challenges with stability, endurance, and autonomy. It marks a shift from lab demos to live performance, showing us what's possible when robotics meets reality. China's message is clear: humanoid robots are no longer concepts, they're evolving into real-world tools. And this race was just the beginning. If you're excited to see where this goes next, like, share, and subscribe.